Hi, hello. Today we are talking about the chi-score test. Chi-score is simplest and most widely used in non-parametric test. So there is a term non-parametric test. We know that parametric and non-parametric tests are there. So what is parametric test and non-parametric test? Parametric test it is very simple. In any test, we have some samples. In any statistical test, we have some samples. Our assumption is these samples are drawn from a population and that population follows a normal distribution. So these kind of, if the population follows a normal distribution, then the tests are known as parameter tests. Otherwise, which means if we don't have any idea about the population, if the population is following normal distribution or some other distribution, we don't have any idea, then we can use some other procedure. That test is, so many tests are there. That type of test is known as non-parameter test. Clear, very clear. I think it's clear for you. Chi-score is an example for non-parameter test. So this is the thing. And we write something about this. In some tests, we assume that the samples are drawn from the population following normal distribution. Such assumption is made. The test is known as parametric test. There are situations not possible to make any decision about the distribution of the population from which samples are drawn. In such a situation, we follow test procedure. These are known as non-parametric test. This is the thing. Chi-score is a non-parametric. So now what is chi-score test? Chi-score test is nothing but it's a statistical test. Of course, it is a statistical test, and it tests the significant difference between observed frequencies and expected frequencies. That is the definition for chi-score. So this is chi-score. So now we are going to check what are the uses of chi-score test. For chi-score test, we have 4 uses. These are the 4 uses. First, you can test the goodness of it. You can test the independence of attributes. You can test the homogeneity, and the last one, this is very important, you can test population variance. Given population variance, you can test this. So these are the 4 uses for chi-score test. So this is just a small introduction about chi-score test. Now we have a question. This is my question. A sample analysis of an examination result of 200 students were made. It was found that 46 students had failed, 68 secured third class, 62 secured second class, and rest of are placed in first division, first class. The question is this: Are these? My question is this: Are these figures commensurate with the general examination result? And the general examination result is in the ratio 2:3:3:2 for various categories respectively. That means 2 for failed, 3 for third class, 3 for second class, and last 2 for first class. It's very clear. So what is the question actually? This means this 200 total 200 students attended. This means the total frequency is 200. Clear? So the total frequency is 200. And it was found that means we can observe something. We observed that, which means observed frequencies. We observed that means observed frequencies. What are the observed frequencies? 46 students failed. That these are observed frequencies. 46 students failed. And for third class there are 68 students. For second class there are 62 students, and first class there are we need to find and the rest were placed in first class. That means there are 200 students, total 200 students. We subtract 46 plus 68 plus 62. What will we get? We will get 24. So 24 is the number for first class students. So these are the observed frequencies. We get observed frequencies. And what is our question? Are these figures means these observed figures commensurate with the general examination result? What is general examination result? General examination result is expected frequencies. So general examination result is expected frequencies, and here they are like this. Are these figures, which means observed frequencies commensurate with the general result, which means observed frequencies are commensurate with the expected frequencies. This is a question, which means is there any significance difference between observed frequencies with the expected frequencies? Clear? This is a question. So observed frequencies we know that 46, 68, 62, 24. And for the expected frequencies, they are only given a ratio. They are given that the ratio, which means we have a ratio like this: 2 is to 3 is to 3 is to 2. What does it mean? Which means failed is to third class is to second class is to first class. I think you are familiar with the ratios, how to find out values from ratios. So here there are 200 students. In total there are 200 students. There are 200 students. For this failed section, for failed category, what is the total for this? 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, sorry, 8 plus 2, 8 plus 2, 10. So the total is 10. Here for failed, 2 divided by 10. What will we get? So 40. So this value is 40. And for third class it is total number of students is 200. For this, for third class, this is 3 divided by 10. So you will get 20 times 3 is 60. So this will be 60. Again for third class it is also 3. So this value also 60. For first class it is 2. For first class and failed it is also 2. So for 2 you will get 40. So here also you will get 40. So this is the thing. So these 40, 60, 60 and 40 is the expected frequencies. So now we have expected frequencies and observed frequencies. So what is the question? Is there any significant difference between these observed frequencies with the expected frequencies? This is the question. Okay. So these are the procedure for testing a hypothesis. So what is the first test? First step. So first step is set up a null hypothesis. So here null hypothesis is there is goodness of fit between. You can write like this: there is no significant difference between expected frequencies and observed frequencies. Or you can write like this: there is a goodness of fit between. There is a goodness of fit between observed frequencies and expected frequencies. So this is our H0 null hypothesis. There is goodness of fit between observed frequencies and expected frequencies. Clear. So this is our H0. Next one, decide appropriate test criterion. So we decide what is the test criterion here. Or chi-score is a test criterion. So for chi-score test, how to find the value for chi-score test? This is the value for chi-score test. Chi-score value is equal to summation O minus E the whole square divided O minus E the whole square divided by E. Clear. So next one is specify the level of significance. Level of significance, in this question they didn't give any level of significance, so you can use 5%. So level of significance is 5%, and calculate the value of test statistics. So we need to find the value for the we need to find this value. Next, degrees of freedom, then table value. Okay, so we are going to find this chi-score value. So how to find chi-score value here? What are the observed frequencies and the expected frequencies? Observed frequencies we get here. This is 46. Next 68, 62, 24. expected frequencies. We remember this expected frequencies 40, 60, 60, 40. For this equation, this is O minus E, O minus E, the whole square, O minus E, the whole square. So O minus E. Here O, 40, 46 minus 40. 46 minus 40, you know that 46 minus 40 is 6 and 6 square. 6 square is equal to 36. Clear. Similarly, 68 minus 60, which is 8. 8 square is 64. Similarly, 62 minus 60, which is 2. 2 square is equal to 4. 24 minus 40. So what is 24 minus 40? Is negative 16. Negative 16. Negative 16 square is equal to 256. Clear. Now O minus E the whole square divided by E, which means this value is divided by this value, which is 36 divided by 40 is equal to 0.9. Similarly, 64 divided by 60 is 1.07. Next, 4 divided by 60 is 0.067. And 256 divided by 40. 256 divided by 40 is 6.4. So these are the values. So the chi-square value is sum of these values, 0.9, these values. What is this sum? The sum is 8.437. This is a sum. Okay. So chi-square value is 8.437. So we calculate value. Okay. Now what is the degrees of freedom? For chi-square, degrees of freedom is this n minus r minus 1. Okay. Degrees of freedom is n minus r minus r minus 1. This is the degrees of freedom. Okay. So what is n? Number of values. Here 1, 2, 3, 4. Clear. So n is 4. Minus r. R means number of parameters. Number of parameters means mean, median, mode are parameters. So here there is no parameters. So there is no parameter. So r is equal to 0. So 4 minus 0 minus 1. So 4 minus 0 minus 1 is 3. So degrees of freedom here is 3. Clear. And in this question, the level of significance we can use 5%. Level of significance is 5%. So everything is there. Level of significance is there. Degrees of freedom is there. So from statistical table, you know that what is statistical table. In that table, you can find the table value. So for this table value, this is a table for chi-square test. This is a table for chi-square test. From this table, we obtained a table value. From this table, we obtained a table value. Here, degrees of freedom is 3. So this is 3 corresponding to 3 and 5%. This is level of significance. This is degrees of freedom and this is level of significance. So here level of significance is 5%. 5% means 5 divided by 100. 5 divided by 100 is 0.05. So this is 0.05. 0.05 corresponding to 3. So this is our value. So this is our value. Our value corresponding to degrees of freedom 3 and level of significance 0.05. This is value is here 7.81. So this is our value. So our table value is 7.815. 7.815. Now compare these values. Here this is 8.437 and this is 7.815, which means this table value is less than the calculator value. Clear? Or this calculated value is greater than the table value. So if the calculator value is less than the table value, then we will accept the null hypothesis. If the calculator value is greater than the table value, then we will reject and accept the alternative hypothesis. So this is the thing. Here you can see that the calculator value is greater than the table value. So what we will do? We will reject the null hypothesis. There is no goodness of fit between the expected frequencies and the calculated frequency or observed frequency, expected frequencies and the observed frequency. So this is the result. So what is the conclusion for this? Our decision is this: the calculated value is greater than the table value. So we reject H naught, null hypothesis we reject. What will you accept? The alternative hypothesis. We will accept the alternative hypothesis. Okay. So this is the thing. I think we will get what is the procedure for chi-square test. So these are the procedure for chi-square test. Very simple. First H naught. There is a goodness of it between, or there is no significant difference between expected frequencies and observed frequencies. This is the thing. Next test is chi-square, and you are going to find out the values for chi-square, that is O minus E the whole square divided by E. Then take the sum of these values. That sum will be the chi-square value. Okay, that is a calculated value. Then degrees of freedom. Degrees of freedom, for degrees of freedom you can use this equation n minus r minus 1. Okay, and level of significance. Normally you can use, if they didn't give any level of significance, you can use 5%. Otherwise, if them give any level of significance, you can use that. So with that values, you will get a table value. If the table value, or if the calculated value is less than the table value, then we will accept the null hypothesis. Otherwise, which means if the calculator value is greater than the table value, we will reject the hypothesis. So this is the thing. Okay, and finally here, what is the conclusion for here? Here, this is the conclusion. This is the conclusion. Our conclusion is there is no goodness of fit between observed frequencies and expected frequencies. This is common. This is common. For this question, they are asking, what is the question? These figures are commensurate with the general examination result. These figures are commensurate with the general examination result. That was their questions. So these figures are not commensurate with the general examination result. This is the particular answer for this question. Clear? So in general, you can say that there is significant difference between expected frequencies and observed frequencies, or you can say like this: there is no goodness of fit between observed frequencies and expected frequencies. These are general answers, general decisions. For this question, they are asking, are these figures commensurate with the general examination result? So here, what we get, the table value is less than the calculated value, or calculated value is greater than the table value. So we must reject the null hypothesis. So what is our answer? Here, these figures, that is the observed figures, these figures are not commensurate with the general examination result. So this is a thing. Okay, I think you got the answer. Now, what are the conditions for applying chi-square test? This is very important. What are the conditions for applying chi-square test? So first one is the total frequencies. Here in our question, the total frequencies was 200. There are 200 students, so the total frequencies was 200. It must be reasonably large, which means at least 50 is enough. At least 50. The total frequencies at least 50. Then the second one is expected frequency of less than 5 pooled with the preceding or succeeding frequencies, so that the no expected frequencies is less than 5. Then the degrees of freedom is based on the resulting number of frequencies, which means, for example, our observed frequencies are 6, 8, 10, 12, and expected frequencies are 2, 10, 12, 10. See. In this situation, you can see that this 2 is less than 5. Clear? This 2 is less than 5. Then you add these two rows. This will be observed frequencies like this: 8 plus 6, 14, 10 plus 2, 12. Remaining are the same: 10, 12, 12, 10. The problem is here this is less than 2, so we must combine these two rows. Then apply chi-square test. So in the first time, what are the observations? How many observations are there? 1, 2, 3, 4. After pooling this method, after pooling, how many observations are there? 1, 2, 3. That means in the first time, n minus r minus 1 is the degrees of freedom. That is 4 minus 0 minus 1 is 3. But here this is only two values, so the degrees of freedom will be, here this is observation is 3, it will be 3 minus 0 minus 1 is equal to 2. Clear? This is the pooling method. This is condition. And third condition is distribution. In this distribution should not be of proportion or percentages. These are the three conditions for applying chi-square test. I think you will understand this. If you have any doubts, you can ask me in chat box or means in comment section. I will answer it. Okay, I think you will understand this. Happy? Thank you.